Exactly. No more than 15 minutes. But you might have to wait 0 minutes. You get there like, oh, beep, it's right there. Oh, that never happens. You kind of with me? Mm-hmm. Or you might have to wait 15 minutes because you just missed that one right around the corner right before you came out there. Okay, maybe. So this is what's called a uniform probability distribution. How are the probabilities distributed? Uniformly. So this is a uniform probability distribution. Now here's what kicks a lot of ass about drawing what a continuous distribution looks like. The area is related directly to the probability. So for example, you have a dartboard, right? And if you play darts, I don't really play. It's been a while. Normally get a little drunk and things look better, but as far as how you did. But what's the highest points you can get in the regular darts game? Any idea? So a dartboard looks like this. It's got these little triangles of stuff coming off of it. So of course you get it right there, bullseye. Mm-hmm. Isn't that the best? And the area of that little piece is very small. So the probability that somebody would walk up, just never played darts before, the probability they would throw it and hit it right there is related to the area of that place. So isn't it more likely you're going to get one of these big chunky triangles, right? Of course, it's really likely they're going to get it somewhere in the wall, but let's just not count those. If it doesn't hit the board, we're not going to count it. Are you with me? That didn't happen. Maybe you're with me. So the area is the probability. So if that was 1% of the total area, then what's the probability somebody would randomly get it right there? 1%. So if, let's see if you guys, what's got to be the total probability of any situation? The total probability has to be 1%. So the total area of this block has to be 1. So how tall is this block? How wide is the block? How wide is it? 15. The area has to be 1. So what do you multiply 15 by to make it 1? 1 over 15, the inverse of 15, right? So the height is 1/15. That's the probability for this situation. It's 1 out of 15. So you can think of it like what's probably comes in the first minute or the second minute is 2 out of 15, right? So you can be even more and more precise. So let's say, what's the probability I have to wait 2 minutes up to 8 minutes? What's the probability that I got to wait 2 to 8 minutes? See how beautiful this is. Now that I have the picture, the probability, any probability question, what do I have to find? The area related to that question. So how wide is this block? 6. How tall is a block? Everything's 1/15. Yeah. That's 2/5, right? 40 hundredths, that's 40%. Why is there a 40% chance you got to wait between 2 and 8? Because 40% of 0 to 15 is 2 to 8. That's why. Any uniform probability distribution acts like this. And in fact, to be honest, we're going to make this tie-in a little bit stronger with a certain handout next time. You've got to be careful about that phrase next time. Everybody goes, time to go? No. But the area, if I draw the situation and make the total area 1, then the area of any subgroup is going to be the answer to probability. So in between -1 and 1, standard deviation. Who remembers on a normal? What percentage? 68%. So how big is this area compared to the whole thing? It's 68% of the whole thing's area. Area rules the day when you draw the situation. That kicks so much ass. Why does this shape suck for areas?
Because it's rounded.
Yeah, we don't have a lot of rounded edge area formulas laying around, right? So when we get to these problems, we're going to live off of this chart for probabilities. The chart's created from calculus. We're not going to learn calculus. We're just going to take their results and go, thanks, calculus people. Right? Because if you've ever taken calculus, one big thing it does is it finds the area underneath any curve. That's really one big thing calculus does. That's all I'll say about calculus. Don't freak out. Okay? Ew. That's what you'll say about it, and then you'll stop. Okay. So that's later. But it's this area idea, which is just awesome. Can anybody tell me, figure out, don't say it out loud, what's the probability that I have to wait between 1.29 up to 13.87 minutes? See if you really understand what's going on here. It really is just finding the area of a rectangle. Yeah, because how tall is this rectangle?
1/15.
And how wide is this one?
12.58.
12.58? Yeah, that's about right. So 12.58 times 1/15.
83.87 or something.
Who to what? Sorry?
0.839
839.
or 8386.
Beautiful. I like it because we all know now 4 places.
That would be 7. Then.
7.
Yeah,
Okay.
7 because it goes, it's 6, 6, 6, 6, 7.
Hopefully you guys don't think I'm doing that in my head to check. So thank you. 8387. All right, was that ugly? Was that hard? Were the numbers beautiful? No. Can you use a calculator? Yeah. It's just finding the width times the height. It really is just finding the area of the picture that represents the question. That is beautiful. It happens in a lot of mathematics. It's a hard problem algebraically. If I graph it, it's an easy problem. So many times if I change the representation of the problem, it's easier to do, and then I just bring it back. Maybe. So let me give you a different situation and ask you some questions.
Yeah, camera.
Is he dead? Is he going still?
Yeah.
I forgot to clear him from this weekend. Oh well. We'll see how much room I got on there. So let's say I have a uniform distribution from 7 to 39. Draw that, find the height. Go. Draw this, find the height. That's true. Yeah.